All right, Chapter 6, Welding Aluminum Alloys. Aluminum alloys commonly used with the construction pressure for the cryogenic vessel piping system. The accuracy specified with Aluminum Association Incorporated, American Society Test Material, Military, other federal specification. Aluminum welding electrodes fill their rods for the specified American Welding Society A510 military documentation. 6.2, Welding Aluminum Alloys. Introduction. Most aluminum alloys can be joined either by the gas metal arc welding or gas tungsten arc welding process. Welding aluminum alloys is essential to the same both processes. Most commonly easy to weld alloys through the non-heatable treatable I3X, 1-3X, 3-3X, 5-3X, and heat treatable 6-3X series and 7-3X series. Only two alloys of 7005 and 7039 were developed specifically for welding. One non-heat treatable alloys. The composition of non-heat treatable aluminum alloys determine the relative mechanical strength with an increase with the cold temperature, age, temper with the strain hardened with the alloys enabled the O temper condition to have the weakest mechanical property mechanisms containing the alloys of the F5X, 5-3X, typical given with low temperature stabilization treatment with lower strength temp slightly increase the ductility to produce some precipitation preheating of the annual weakened straight hardening material. Heat treatable alloys appropriate with the solution quenching of the precipitation reaction produced by the heat treatable alloys with the maximum strength. This age hardening mechanism requires the alloy element with the applicable to solid volatility in aluminum evaluated temperatures, both limited solubility with low temperature. Typically, the thermal treatments first involve the solution of the heat of the treatment that is heating with a 900 to 1,000 degrees Fahrenheit with the range below euatic melting temperature. At this temperature, the maximum amount of suitable solute is taken. The solution, the W temper, and the question the much of the solution treating temperature is non-equable unsolid super saturated solid solution is obtained with the quenching rate of the critical for some alloys composition, particularly through the 550 to 750 Fahrenheit range. The degree of the quenching sensitivity depends on the alloy composition. Some precipitation from the supersaturated solid solutions are at the room temperature strength of the alloy. However, the natural age with the approach of the maximum strength of the T4 temp of course the rate of the natural aging with the strength produced with the variable the alloy composition holding the reducing temperature of the slow precipitation material undergoing the natural aging. If the material which has been solution for the treated with the quench is heated with typically the 300 to 500 degrees range, the desired precipitation curve of the marked increase with the alloy mechanical temperature T6 temper heating, and though the high temperature of 500 to 800 degrees Fahrenheit results in non-strength participation of the solute element. The annealing heat treatment tends to produce the equilibrium structure with the high ductility load strength O temper. Alright, B, welding procedure. Welding procedure should be qualified before the work with proceed with the structure. Chapter 2 with the welding procedures, depending on the base plate, the structure is being welded, the position of the weld, the flat, overhead, horizontal, vertical, the chemical composition of the metal, for the proper the welding. Aluminum must be cleaned with all foreign materials, must be removed with the joint. Air with the contamination do not become the fluid from the heating of the weld flow into the joint. Cleaning is the most effective adjustment before the welding. However, the welding supervisor can be set suitable time limit based on the shop conditions and requires of the product. The three methods commonly used in cleaning aluminum is solvent, decreasing and mechanical cleaning, and the chemical etchings cleaning. 1. The solvent decreasing and remove the grease of the oil and the loose particle with the most effective with the metal surface is smooth when the contaminants are not tightly adhered to. The solvent includes a wide range of commercial product with the acetone, chlorine, chlorethane, NU, but should be used with the hydrocarbon such as the carbon tetrachloride with the trichloroethanol. These break down the presence of the welding area to form the high toxic gases such as physogen. Safety precautions should be observed when using all the solvents. Mechanical methods of cleaning include wire brush, scraping, the filing, the planing, grinding, and the rubbing of the steel wool. Because these methods are costly, they should be used only for the welded areas. Wire brush may be done with a hard brush, power rotator brush. Both the type should be stainless steel brush. If the brushes may be kept clean with the bristles become dirty, but they become degreased with the solvent. Likewise, those discussed above. Before brushing, the joint area should be degreased, but if it is done, the brush will stay clean. Will not drive the contaminants into the aluminum surface. Burnish the aluminum surface can be also been trapped. Therefore, only light pressure should be used before pouring the brush. Cleaning the grinding is best done with an open coat aluminum oxide disc 80 grit. The process is especially useful moving the heavy oxide film associated with the water staining and wire brush chemical etching are not effective after the mechanical cleaning of the metal should be decreased. Alright, 3, chemical etching, which is the use of the batch of the cleaning with the produced with the surface of the tree with the contamination of heavy oxide films. However, the etched surfaces tend to be more absorbent within before they thus can be recontaminated. If not protected, they should be cleaned or just before the welding. 4, improper procedure, particularly with cleaning can be reduced. The defects of the welding joint that include the porosity, the tungsten inclusions, the inclusion of the fusion, inadequate joint penetration, undercutting, cracking, limitations on the various defects of the governed by the American Society of Mechanical Engineers boiler pressure vessel code per military specification, whether the defect is severe enough that it's acceptable dependence on the function and finish of the product. The cracking. Sensitivity of the welding and the cracking largely dependent on the welding composition, both the base and filler alloy composition. Effect of the resulting welding being composition, the welding heating, the relative percentage of the base metal with the filler metal, the welded metal with the filler of the joint design, significantly influencing the relatively percentage of the base metal welded in most alloy systems. There are one or more regions of maximum crack sensitivity in the base of the metal composition. For the high cracking sensitivity, the filler alloy contains a high percentage of the magnesium are used, but the change of the composition of the welded metal is less sensitive to cracking the minor alloy elements. Also change welding cracking sensitivity to particular grass finding elements for the titanium and zirconium, and frequently added to reduce the cracking tendency of the filler alloys. Minor amounts of copper and aluminum, magnesium, zinc alloy greatly increase the cracking sensitivity of the copper. The contribution in formation of low melting phases with the segregated with the ground grain boundary shrinkage stress during the weld. Solidification can be caused with the boundary separation before the low melting phase solidifies. 1. Crater cracks. Crater cracks are most often encountered with aluminum welding. They are small checks of the crow's foot defects which occur during the solidification after the welding has been broken. Such that the cracks may be small but very serious and sensitive. They usually at the end of the weld may be serious. Concentration and effect of the deposit most be pronounced. The number of the crater cracks can be eliminated with a good welding practice. They usually involve the proper manipulation of the torch and filler. Both of the technique most often to break with the restart with several times so the shrinkage pipe at the center is filled. But in addition with the run out of the tubes, I often use to prevent the crater cracks. The welder should be checked carefully with those cracks and should remove them from the remove them before rewelding. And very hard to remove the crater crack by remelting the weld. 2. Longitudinal cracking. Cold longitudinal cracks are not usually found with aluminum welds, but the hot cracks sometimes occur when the metal is passing between liquidus and solidus form. These cracks usually form caused by incorrect filler alloy to lower or too high welding rate and an incorrect edge of the preparation of the joint spacing. With the old cracks will occur below the solid temperature. They usually result when the teeth to a small welded bead is laid down. The cold cracks should be eliminated with weld bed large enough to withstand the cooling stress encountered during the solidifications. Other defects of the defects can be introduced with the welding metal with the improper welding process technique is used. The defects include the porosity, the tungsten inclusion, incomplete fusion, inadequate joint preparation. Undercut paragraph 4.2 the discuss the incomplete fusion, inadequate joint preparation. Undercutting the information applies to the aluminum as well as stainless steel. Porosity, shrinkage porosity are associated with the overheating with the gas porosity of the common defects of welds. Cylindrical gas pores are found most often the hydrogen accepted as more occurs with the porosity in aluminum welds. Hydrogen usually results from the water hydrocarbon contained over the base plate of the filler wire, the shield gas or arc column. The size of the number of the gas pores with the existing hydrogen concentration vary with the welding metals of the solidification porosity formation, nucleation at the growing process of the fate solidification rates, and not enough time with the nucleation step. The lower pores can be set, and even at the high hydrogen concentration, a slower solidification, poor nucleation, slow growth occur with the bubbles are trapped in the freezing metal before escaping. Slower solidification rates make available the pores to grow with the gas to escape with the molten pulp. The solidification rates for the show slow enough to all the gas escape the non-porous remaining with the weld to be recommended scattered porosity that is usually detected radiographically. It has the effect of the mechanical property. Of course, the larger the amount of the gross property reduces the metal crossing sectional area loss, lower while the strength of aligned lower layered porosity. If it has greater effect on the mechanical properties, microporosity is too small, but the detected standard radiographic techniques typically occurs in lower layers around with the welded fusion line. The defects lower mechanical properties considerable. Tungsten inclusion. Tungsten inclusion occurs only when the gas tungsten arc welding process you use. The tungsten becomes trapped in molten welded metal, but because who transfer profit the electrode diameter small, but the welding current metal, but the tube march to the end with the mechanical joisting torch for the complete with the tungsten to be transferred. But the welded puddle of the tungsten also can be transferred if the electrode is touched with the welded metal. With the tungsten includes the electrodes with the current diameter with the proper taper ground with the end of the should be used. 6.3 Joint design. Weld the joints prepared mechanically, machinely grinding with the plasma cutting before welding the joint. Surfaces are being cleared of all foreign materials such as paint, dirt, scales, oxide, solvent, cleaning. Light grinding to etching can be used. The joint surface should not be nicked or gouged since they can and hinder welding. In the American Welding Society Welding Handbook, Chapter 69, Aluminum and Aluminum Alloys, has a section on design joints for the welding. Their theory of the practice of designing aluminum joint structures are discussed. Joint accessible, edge preparation, stress distribution are covered. 6.4 Methods of welding and aluminum alloys. Best welded result, careful cleaning with the joint of the proper selection of the filler. While with good welding practice, the aluminum oils can be welded with service process of choice depends on the condition of such a thickness, size, parts, location, position, welded number, the timer, weld production required, finish appearance desired, and type of the aluminum alloy welding processes. Having successful gas or carbon arc, the atomic hydrogen, gas tungsten arc welding, gas metal arc welding, in an area. Shield welded process used with all positions, including overhead aluminum alloys, cryogenic applications of welded either the gas tungsten metal arc welding and gas metal arc welding. This manual discusses only the inert shield arc welding process. Most of their style commonly used with the field fabrication. Preheating the joint welding joint is not commonly recommended, but if ambient temperature low, reheat not more than 300 degrees Fahrenheit can be applied with the joint before welding. The properties of the metallurgy aluminum alloys are almost always affected adversely evaluated temperature. Therefore, the preheating is not recommended. Heat should be applied briefly as possible. Alright, 6.5, gas metal arc welding. Using gas metal arc welding increasing the chop of the application because of the economics of the process, the loss of the downtime electrode change, but the loss of the loose to the sub-end splatter of the most and last. Much of the less interpath cleaning required gas metal arc welding can be used with all position, either short circuiting transfer or impulse voltage power supply. No flux is required for the welding aluminum with the gas metal arc welding process. It eliminates the costly flux removal with the possibility of the post-weld corrosion during the flux residue. Another outstanding characteristic of the gas metal arc welding process is to use high welding current density with the density of the wire common range for the 60,000 to 300,000 amperes per square inch. The high current density coupled with the very efficient heat transfer and arc, resulting in higher welding speeds, low distortion, low welding costs, better mechanical strength, better corrosion resistance than can be obtained with any other welding process. Aluminum, high current density with efficiently heat transfer the arc produce the dense penetration, makes process good for fillet welds and any reduce the need of the edge preparation for the more detailed Chapter 3. Electrode classification. The classification code for the gas metal arc welding electrode wires consists of an E and an R. The 4-digit configurations an E and R X4. Prefix R indicates the material is suitable for the reuse as a welding rod, and prefix E indicates it's standing as an electrode. The filler metals can be used by the electrode gas metal arc welding as welding rods with gas tungsten arc welding. Both letters E and R indicate that they are suitable for either the welding rod or an electrode. Such an electrode meets the test prescribed in the American Welding Society. A510 can also be used either electrode by the welding rod. The 4 numbers of the electrode classification system refer to the alloy chemistry of the rod and electrode. For example, the ER1100 classification would be an electrode the rod having chemical makeup of equivalent of 110 or 1100 alloy aluminum. Chemical requirements American Welding Standard F510 contains the chemical requirements of GMA electrodes. The portion of the elements are similar with the electrode base metal with the same designation. All chemical analysts are based on the as manufactured electrode wire. Welded metal mechanical properties for aluminum welded metal. The American Welding Society A510 specifies on ductility, pressure for the bending of the test, not strength and impact resistant levels. Shield gas aluminum argon shield with the gas for the CMA crosses argon is more often the availability used for the helium or rapidly because of the helium low density great value required to produce the necessity of shielding, but well deeper than possible becomes the higher ionization potential. Argon is better than manual welding because of the instability of Y for the pure helium. Helium argon mixture is already being used for the more semi-automatic welding, but both structures are poor pure helium are widely used automatic welding to obtain adequate welding penetration. Helium alone or a mixture of the helium and argon may be preferred for the welding very heavy sections more than 2 inches thick. This mixture, 75% helium and 25% argon, is commonly used and available to pre-mix. Recommended filler metal for the aluminum alloy welding. Aluminum alloys listed with the AA specific numbers in the table entitled with the guide to the choice of the filler metal for the general purpose welding. Appendix 1 of the American Welding Society A510. There are also American Welding Society Welding Handbook, Chapter 90, Aluminum and Aluminum Alloys, American Society Materials, Metal Handbook, Volume 6, Arc Welding of Aluminum Alloys. Alright, gas tungsten arc welding. Gas tungsten arc welding is aluminum with an alternating current superimposed on highly efficient with the atmosphere argon gas industry. The gas tungsten argon arc welding with DC straight polarity helium gas is received to increase the tension. DC gas tungsten arc welding is only with a very low currents because of the overheating of the electrode. However, this is the process seldom used because of the accumulation of tungsten inclusion noted in paragraph 6.2 with the tungsten gas metal arc welding. The gas tungsten arc welding does in use the flux welding arc and the argon gas remove the aluminum the oxide filled with the surface of the metal with the argon should prevent the reform of the gas tungsten argon weld. The gas tungsten arc welding will have good appearance require lift, and if any of the grounding efficient gas tungsten arc welding process can produce X-ray qualities in either weldable aluminum alloys under proper condition. Gas tungsten arc welding may have sounder structural over than welds made with other presence and excellent penetration is obtained on the butt welds that have been properly prepared. However, the care and the experience is required to obtain the adequate penetration on the fillet lap welds, and since the tendency to bridge routes unless the adequate current with the short arc are maintained, the AC gas tungsten arc welding is usually confined to a thickness below a quarter inch. The gas metal arc welding process of DC straight polarity gas tungsten arc welding is generally thicker sections. Gas tungsten arc welding is normally used for the most of pipe welding for joints where abrupt changes in direction of the welding encountered almost always for welding aluminums less than 1/16 of an inch thick have high quality welding made with all position. For additional information welding processes, see Chapter 3. Alright, electrode classification system. The classification code for the gas tungsten arc welding filter rods it consists of an A and an R 4-digit configuration number. The ER 4X. Letter E indicates electrode material. R indicates the welding is a welding rod. Since these filler metals can be used with the gas metal arc electrodes as well as the filler rods of the gas tungsten arc welding, both letters are used. The 4-digit number such as the 1100 in the ER 1100 designates the chemical composition of filler metal specification of those electrodes in American Welding Society of A510. Chemical requirement. The chemical composition of the gas tungsten arc welding rods are listed with the American Welding Society A510. Proportion of the elements in similar electrodes base metal with the same 4-digit designation. Chemical analysis are based on the as manufactured welding rod. Welding mechanical properties. For aluminum welded metal, the American Welding Society A510 specifies only ductility measure for the bend test, but not strength of the impact resistant to level. Shield gas. 2 shield gas are used with the gas tungsten arc welding process. Pure argon and pure helium. Argon is thickness of a 1/4 inch or less. Pure helium is thicker material when DC straight polarity is used for machine welds. Recommended filler metals for aluminum alloys. Aluminum alloys are listed in the AAR specifications of the table and entitled Guide to Choice of Filler Metal for the General Purpose of Welding. American Welding Society A510, Appendix A1. A comprehensive list is also in the American Welding Society Welding Handbook, Chapter 69 on aluminum and aluminum alloys, and American Society Society Materials Handbook, Volume 6, arc welding aluminum alloys. Chapter 7, Welding for Special Applications.